The DCube feature platform provides an extensive library of sophisticated fraud features, which are all automatically derived and enriched from standard fields like email, IP, etc. based on your mapping. In feature management, you can review your raw data fields, derive new and customized event and use R-level features and use DataVisor advanced features. These include features are based on our global intelligence network and our deep learning models. Let's look at IP for example. You can see a number of features automatically derived such as IP prefix 20 and more. You can even click to look at the distribution of those features in your data. Now let's look at how you can create your own custom features. DCube supports 4 main feature tiers: Basic, Velocity, Advanced and Deep Learning. Basic features include a library of mathematical or logical operators that you can use on your data to do simple transformations. Velocity features can be used to do time series analysis. Now let's assume you would like to create a velocity feature, which computes the number of applications for each distinct IP in the last 1 month. Since you want to get the number of applications for each distinct IP, you can first select the distinct count aggregation function. Then select application key as the data collection attribute, since it's a unique identifier for each application and that would give us the number of applications. In order to group by IP, you can select it as the entity. Then you can enter a name for our accumulator and a small description so that if you look at our accumulator later you can still remember what it should be used for. DCube also supports advanced filtering capabilities. For example, you can filter out unsuccessful applications from your calculation. Finally, you can configure the time window of the accumulation. First, you can select the time range to accumulate for, which is 1 month, for this example. Then you can also select an offset, which can move the starting point of the accumulation. This is in case you would like to exclude some very recent data. Now you can just enter the new feature name you want and a short description to remember its function. You can also categorize it according to the type of fraud it's designed to detect, but DCube also supports custom tags that you can share with your team. After you configure your velocity feature, it's a good idea to test it on a sample of your data. You can select the number of events you want to test on, and examine the values of your velocity feature right away. Next, let's move to the advanced feature section. Here, we support a very wide range of operators that follow a specific template. Each operator comes with a short description to explain how it works. To add a new feature here, you need to configure the following: a source feature, which is the existing feature to be used as input to the operator, then a number of operator-specific parameters, lastly, a name for your new feature. So now, with that in mind, let's dig a little deeper to the different types of operators DCube supports. At DataVisor, we understand that every company's data is different, so we provide pre-processing feature functions to help the user massage the data in a way that makes sense for each use case. For example, if you have offline applications in your dataset, which may be missing some fields such as income, you may want to remove some invalid values. Another type of operator we support is event-level feature functions. These operators apply to every event in your data. For this example, you will use the bucketize for attribute operator to bucketize the credit limit amount to make it a bit more robust to noise. Finally, let's look at a more complicated feature. Sometimes, you may want to derive cluster-level features, which describe some behavior patterns of a cluster. Let's say you want to derive a feature, which measures the diversity of the approved credit limits within the cluster. To do this, you select the isDiverseValue operator and select credit award amount as our source feature name. Then select the threshold for the median absolute deviation of the credit limits in a cluster. If the cluster's MAD for the credit limits is over that threshold, then the cluster is marked as true for that new feature you created. If the operators supported by DCube are not enough, we also support creating features by coding. This is a small editor, which currently only supports Java. Let's say that you want to check if the applicant's last name appears in the applicant's email address. You can use the $sign to reference a field name to get its value. Of course, there is not bound in the complexity of the features here. You can test your feature using the test button, which will test your code for a few hundred records. In Feature Management page, you also have access to 2 advanced DataVisor feature engineering tools: Global Intelligence Network or GIN, and NLP Deep Learning features. Let's walk through GIN features first. To enhance detection efforts and enrich decision-making, DataVisor leverages its Global Intelligence Network (GIN), which is comprised of anonymized non-P data from over 4 billion protected accounts and 800 billion events across the globe. The GIN contains rich information on digital data such as IP address subnets, prefixes, proxies and data centers, user agent strings, device types and OS, email address domains, and more. Information from the GIN feeds into machine learning algorithms to further improve overall detection. For example, let's assume you would like to create a Boolean feature that defines if an IP subnet is likely to be fraudulent. You will create this new feature by encoding the GIN features IP prefix 20 bad rate and IP prefix 20 all user count. The former is the fraction of users accessing from an IP20 subnet that are fraudulent, and the latter is the total users accessing from the IP subnet. Now you define this Boolean feature like so: when an IP subnet has more than 10 total users, and more than 50% of these users are fraudulent, the B Boolean feature is set to true, otherwise, it is false. Now save the setting, you can see it appears in the feature platform page, and it's ready to use. Now let's add new features with DataVisor NLP Deep Learning Models. DataVisor NLP Deep Learning Models provide fraud signals indicating levels of suspiciousness for given accounts. These signals are derived from user-generated content such as usernames and email prefixes, and are a key component of our best-in-class fraud intelligence. The advanced deep learning algorithms draw from the sophistication of multi-layer deep learning algorithms to rapidly surface unusual naming patterns at the cluster level, and provide a precise fraud signal for enhanced decision-making. The deep learning operators can be configured from the Deep Learning Feature tab. Some of the available deep learning models are email model, email prefix model, and full name model. The former two determines if emails of a cluster is likely suspicious, while the first one taking consideration of the full email string, the second one only looks at the prefix. The last model gives a suspicious score to username. There are a number of parameters to set. For example, min, max input length limit the number of feature values to feed to the model. Sort, dedup and lowercase parameters specify how to transform the feature value strings. Lastly, the extraction method defines how to obtain feature values from each user in the cluster. It currently supports all, recent, concat, and concat sorted time. For example, recent will get the last seen value of each user. All of the features you create will be shown in the Feature Management Overview now, and are ready to be used.